So today, class, we are recording now. Okay? We are going to learn about something. What are we going to learn about? Let's start again. Where'd my recorder go? Sorry. Okay. So there we go. So today we are going to learn about the different types of real numbers and a few other things. Real numbers as opposed to non-real numbers. Non-real numbers are like imaginary numbers, like they're called I, like the square root of -1 and stuff. You don't have to worry about that until you get to pre-calc. So the first type of real number is called a natural number. Okay? Natural numbers, and those are just the counting numbers, basically. Okay? And so those are just 1, 2, 3, 4, on forever. Okay? 51, 73, 1,287, etc. Is 72.5 a natural number? No, because it's got to be a whole number, and it's got to be start out 1. So whole numbers. The only difference between whole numbers, I shouldn't tell you this because this is on the little sheet that you're reading. Whole numbers, okay, are the numbers, right? The only difference between these and those is that there's a 0 in front. 1, 2, 3, 4, on the yes, ma'am.
I don't get it. Why would you
70, it would be, yeah, but 72.5 would not be. Yeah, nothing with a decimal or fraction. Okay? So those are the whole numbers. Only difference between whole numbers and natural numbers is whole numbers have 0. I guess natural numbers, you could count them. Whole numbers, you can't really count as 0. Can you count as 0? Okay. Then we have something called integers. Okay? And integers are all those numbers on my number line over there. See my number line back there? We put that up and this here. Integers are negative or positive whole numbers. So anything from on a number line going from like -5, they could go -4, -3, -2, -1, 0, 1, 2, 3, 4, etc. Up this way forever, and it goes down that way forever as well. Okay, those 3 dots mean they go on forever in either direction. Okay? So would -63 be an integer? Yes. Would -63 be a whole number? Would -63 be a whole number? No, right? Because whole numbers are only 0 and positive. All right. Next one is called rational numbers. And rational numbers are numbers. Rational numbers. And the reason that they're called rational is because they're relatively straightforward to express. So those are numbers like 3/5, or numbers like 1/3, or numbers like the square root of 9, numbers like 0.222 with a little bar on top. What does that mean? It goes on forever. Okay? Or repeats. There's other ones that repeat, like 0.171717. And those 1/7 go on forever like that? Okay. 0.17, no, you write a bar on the top.
What do I know, like, if you're doing,
Oh yeah, you could just do one of them. That's it. But some numbers repeat forever and ever. Okay? So those are rational numbers. And rational numbers are any number, that wasn't a very good number. Any number that can be expressed exactly as a fraction, okay? Or, look at my notes here. As a fraction or repeating decimal, right? Or repeating decimal. For instance, 3/5, that can be expressed exactly as a decimal, right? Anyone know what 3/5 is? 660. So it's 60%. Yeah, so 3/5 I could write as a decimal is 0.6. Okay? Anyone know what 1/3 is?
yes, that's
0.33 repeating forever and ever and ever and ever, right? So 1/3 is also a rational number. What's 9? What's square root of 9? Anyone know what that means? Yes, Lauren? Oh, Lauren, what? You're not there. Sarah. Lauren, Sarah. Can I call you Lauren? Okay, and put your cell phone away, or I will. Okay? Thank you. Okay, 3. Very good, Sarah. So Sarah says that the square root of 9 is 3. Can that be expressed as a fraction? As what? Very nice. 3 over. So if I wanted to express it as a fraction, it's 3 over 1. So are natural numbers, are they rational numbers? Are natural numbers rational numbers?
wait, natural numbers?
Are these numbers, can they be expressed as a fraction? Yes. Yes. Are all rational numbers natural numbers?
No.
No. Okay. So we'll make something called the Venn diagram, okay, to kind of express how this works, okay? Then we have irrational numbers, and those are numbers they just get crazy all the time, okay? Irrational numbers are numbers that can't be expressed exactly as a fraction or repeating decimal. Can anyone think of one like that? Like numbers that go on forever and ever and ever and ever and ever and ever. Yes, Jordan. What is give me an example of an irrational number? One that goes on forever and ever and ever.
Oh, I don't know.
You know, who knows one? What were you going to say? What are you going to say there, Jason? Pi. Very good. Pi.
Pi doesn't go on forever.
Yeah, it does. Scientists have tried to prove forever, or mathematicians, that it stops somewhere. And you can get a very close, a very close approximation to pi as 22 over 7, some 22 over 7, but it's not exact, right? And if I try to divide 22 by 7, I wouldn't get something that repeats. So pi is about 3.14159, and then I don't know what comes after that. Some of you had Mr. Lemke or something. They said that he had them memorize digits of pi or something, and some kids in my class repeated all the way to like 100 digits or something. But it never repeats, and it goes on forever and ever and ever and ever. And we will find out where that number comes from. But it is not a repeating decimal. There's another one in math that you'll learn when you get to like algebra 2 called E. And E is about, you don't have to know this, but it's about 2.73 something, blah, 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 blah. And that comes up a lot when you're dealing with interest rates and things and stuff like that. And but that's another irrational. But another type of irrational number is a simple little thing like square root of 3. Okay? Square root of 3, square root of 9 is, that says, what's the number that I need to times by itself to get 9? What is that number? What number do I have to times by itself to get 9? 3, right? What number do I have to times by itself to get 3? It's between, what two numbers would it be between? It'd be between 1 and 2. If you do this on your calculator, you get a number, it's not 1.5, it's like 1.732, and then it kind of keeps going on forever and ever. So any square root that's not exact, that's an irrational number as well. For instance, root of 5, that's an irrational number. How about root of 4? Is that irrational? No, because what is root of 4? Huh? 2, right? So this one is not an irrational. Okay? So that's how that goes with rational and irrational. And then they'll have some example problems like this. Okay. So new page. Okay. So what if you had a question like this? Which type of number would you use for expressing the number, this sign means number for shorthand, of students in your class? Would you use whole number, natural numbers, whole numbers, natural numbers, integers? What would you use? What would you use there? Someone else? What would you use? Okay, Sarah. Natural, right? Because those are just the counting numbers. Probably not whole numbers because you can't really have 0 students in your class, right? What if you want to express the time in the 100 meter dash, which some of you saw with that Bolt guy, right? Do anyone know what his time was? What would that be? Rational? Yeah, I think you might express it as a, what do you think? A whole number? You're going to have seconds. It wouldn't be a whole number. But like, something like, what if to the nearest 10? So it'd be like 10.7 or something like that. Would that be a rational number or a real number or irrational? What do you think? Or an integer? What? We're gonna work on it, right? What do you think? What's that gonna be? Time in the 100 meter dash. I think that's just rational because this can't be expressed as a fraction as 10 and what? How many tenths is that? How many tenths is 0.7? 7 tenths. So I could write that as 7 tenths. Alright? So that would be a rational number. Right? Because it can be expressed exactly as a fraction. Like 10.7. What if I had, here's a good one. What if I had any golfers here? Golf scores for the pros. For the pros. For the pros. The pros. Anyone know? What do you think? Yeah, how come? Or is that what you were going to say? Integers, how come? What? Yeah, because you could have negative, right? But then, you know, like Tiger Woods or Tiger Woods isn't so good anymore. But you could have, Tiger Woods is 7 under, right? You can't be 7.5 under. Either you're at par or you're under par or you're above par. Could they be even par? If they're even par, then their score is 0. If they're above par, then their score would be like 3 or 4 or 5 or 6. Usually with the pros, under par wins, right? So they'll say, Tiger's at -7 or -8 or -9. You know what that means, par? Like if you're a regular, like even par means you're shooting what you should shoot on the golf course. If you're under par, it means you're shooting better than you should shoot on the golf course. Like the normal golf course, it's like 72 is par usually around there, and they'll shoot like 68. So they'd be like 4 under par. Me, I shoot usually like 10 under par. Not really. I shoot like for the first 9 holes. No, I usually shoot 72 for 9 holes. That's not very good. All right. So, yes, ma'am. That would be, I got it sidetracked. I'm talking about golfing. Integers. Yes, it would be integers. Okay. Okay, so I don't think I'm not going to talk about this other stuff quite yet. Should I? We're almost done. Let me just talk about a couple more things. And then I'll let you work on this top hat back. Okay? So then we have these symbols called inequality symbols. We've been talking for 17 minutes so far. Okay? Inequalities. Inequalities. All you have to do is look on the back up there. I posted them up there. Inequalities. Right? This thing means, what does that mean? That means less than. Okay? Less than. Yeah? Less than. Less than. What does this mean? Greater than. Greater than. This means less than or equal to. Less. I'll write out the whole thing. Should I write out the whole thing? Okay. Less than or equal to. And this means greater. There's one more. Greater than or equal to. And then there's one more. And you want to know what that means? What does that mean? Oh, it's not up there. Guess what it means? Yeah, it means not equal to. Not equal to. So you'll see some problems like this. You'll say 3/4, and then they'll say put the correct symbol in between 3/4 and 3/7. Ooh, I give you a hard one right after that. Which one's bigger? Which one's bigger? 3/4 is bigger. So the big mouth goes towards the bigger number. Because this, if I change it in decimals, 0.75, this is something less, right? Sevenths are smaller than fourths, so if I only have 3 of them, right, I'm going to have less of my pie. So this goes this way. Oops, no equal sign. So that would be, let me erase that. It would look something like that. What if I did like 0.25 and 1/3? Which way does the mouth go? Which way should the mouth go? 0.25 and 1/3. Right? Which way should the mouth go? which way? Towards the 1/3. Okay? And so on and so forth. Okay? So that's all there is with inequalities. That's pretty easy. It'll ask you to arrange things. And then they have something called the opposites. Opposites are just, you change the sign. Okay? So the opposite sign. So what's the opposite of 3? Negative 3. What's the opposite of negative 1/2? Positive 1/2, and so on. Okay? So that just means change the sign. And the very last thing that I'm going to teach you new today is absolute value. Absolute value. And absolute value has a lot of practical applications. But if they say the absolute value of negative 3, okay? What is that? Exactly. Go ahead. 3, right? What's the absolute value of 3? It's also 3, okay? And you say, how could that be? Because what absolute value it says take whatever that number is and makes it positive. But it is also the distance, it's the distance from 0, distance from 0 on a number line, okay? So for instance, if I were to do a number line, which I'm about to try to do right here, in Mr. Leader's cutting edge technology math class, okay? Here's a number line, right? And here's 0. And I say negative 5. How far is negative 5 from 0? 5. Okay? So 5. So the absolute value of negative 5 is 5. What's the absolute value of 3 minus, here's a tough one, 3 minus 5? You guys know that? Who's got that answer? Absolute value of 3 minus 5. Yes. Sorry, I forgot. Like 2. Right? Do you see where we got 2? Because this is equal to 3 minus 5 is negative 2. So you treat it just like parentheses. And the absolute value of negative 2 is positive 2. One more, and then I'll let you work on some stuff. Okay? What if you see something like this? 1 minus 4, that's a 1 minus 4 and absolute value sign. And then over here, I have 2. And they ask you put an inequality sign in between these two. Which is bigger? 1 minus 4, absolute value of, or 2? Which is bigger? Why, Evangeline? Very good. So what she said, when she simplifies this, this is negative 3, right? And when she simplifies this further, this turns into 3, right? The absolute value of 2 is 2, and so it looks like that. Very good. Here you go. Okay, so that's, I think, about all the teaching before we start on the homework. Okay? So, oh, we could stop now. I'm going to stop